All right, so today we're going to start to learn about how to write functions as power series. So if the function is a certain type of function, it's really not so bad to do, but it only works for a certain type of functions. So we're going to look at that first. So if a function looks something like this geometric sum right here, like if it looks something like that where x is right there, then we get a pretty good way of working backwards to write it as a power series, which is x plugged in right there. So for instance, if we had 1 over 1 minus x, well, that would mean our a is 1 and our r is x. And we would just plug in. But we have to have this 1 here, and this has to be a minus sign. And then that gives us our interval of convergence like that. All right, so that would only work for x between -1 and 1, would be the power series for it. All right, so let's take a look at something like this. Find a geometric power series for each function and its interval of convergence. So here's our function. We want it centered at 0. So one thing I want is I want the 2 to be in front and the x to be in back. So I would rewrite this as 4 over 2 plus x, like that. But I don't want to have a plus sign. I want to have a minus sign. So we could write this as 4 over 2 minus negative x. So now I've got the minus sign. Now the big thing I need is this 1 out in front. So what I could do is just divide everywhere, top and bottom, by 2. As long as I do the same thing to the top and the same thing to the bottom, I haven't changed it. Like the fraction is actually still the same. So I get 2 on top, 1 minus negative x over 2. And now it's in this form. It's got some number on top. So this is my a. 1 minus down on the bottom. So that means this is my r. So I could write this as the sum, and it's from 0 to infinity, n equals 0 to infinity, of a times my r, which is negative x over 2, raised to the n. And my radius of convergence is, or my interval of convergence is absolute value of negative x over 2 is less than 1. So in other words, the absolute value of x over 2 is less than 1, or the absolute value of x is less than 2. So there's where it's going to converge. All right, now this is kind of sloppy. In fact, I could clean this up a little bit. And the way we could do that is, well, I could separate the parts. Like, so we got a 2 out front. I've got negative in front of an x. I could say that's negative 1 to the n and x to the n, like that. And on the bottom, we have 2 to the n, like that. Now, if you notice, one of these is going to cancel. There we go, n minus 1. We had one less of them. All right, so now we can say this is the sum from n equals 0 to infinity of negative 1 to the n, x to the n, 2 to the n minus 1, like that. All right, there's our guy. Wasn't so bad, was it? Let's try another one. All right, so I'm going to change colors. I don't like having to use red all the time, but it always defaults to red. All right, so another one, we want this one centered at 1. All right, and I don't see any sort of 1 minus to have on the bottom. So what we can do is we can write this as 1 over 1 plus x minus another 1. All right, so I added 1 and subtracted 1. Those technically cancel each other out. Now what I can do is change this to 1 over 1, and I want this to be minus my x. So I'm going to pull out a negative, and it's going to leave me with x plus 1, like that. That's centered at negative 1, isn't it? How do I get that centered at 1? All right, well, I guess we'll just keep going, because that's the only thing we can do with it is centered at like that. So I guess we're centering at negative 1 instead of 1. All right, but now we've got 1 minus in front. Ah, you know what we did? We didn't put the negative in here. Ah, there we go. Now that's what. Okay. Little brain fart there. It's late in the afternoon here for me. It's almost my bedtime. I'm old. All right, so that's really what's going on in there. So now that is, in fact, the same thing as that. So we didn't just take out a negative from just the 1. We also had to take out a negative from the x, so minus negative. There we go. So our a here is the 1 on top. This is my r. So we get that this is the sum from 0 to infinity of 1 times 1 minus x to the n, like that. And this will converge whenever the absolute value of 1 minus x is less than 1. If I factor out a negative from this, this is the same thing as x minus 1 being less than 1. All right, just pull the negative back out and go right back to that. And the absolute value takes care of the negative. So we get x minus 1 is less than 1. It's greater than negative 1. If we add 1 everywhere, we'll get it goes from 0 to 2. And that's where it converges, and that is the series for it. So we can rewrite this guy as that. Kind of neat. All right, so that's it for this. All right, they will get tougher. So in the next video, we'll look at something a little bit tougher, but that's it for now.